Thank you for being here. We are glad to present our work about hybrid image search we have made at Adeo. It is an e-commerce work, and it is still in progress, in fact. And currently, it is tested by our business owners, and we get many feedbacks from them. And I hope the lessons we get from them will be useful for us, for you, and your feedback are welcome as well. Let's Guitte introduce yourself.
Yeah. So welcome everyone. Again, we're glad to be here today with you. So my name is Guilherme. I'm a Brazilian, currently living in France. I have 15 years of experience in tech industry, 12 at Adeo. I did different missions, and currently I'm engineering manager on the recommendation system. Okay.
And I'm François Gaillard. François is my name. I'm also an engineering manager in Adeo. More focused on AI and data analysis stuff. And I've been building search engines for the last 10 years now with AI stuff. And I'll let Guitte explain what is Adeo.
Yeah, so who knows Adeo? Could please raise your hand? Okay, some people. Leroy Merlin? Okay, good to know. So just to give key figures about Adeo. So Adeo is the third biggest group in the home improvement sector. Okay. We have many brands like Leroy Merlin, the M professionals like Bricoman, Obramax in Brazil. Almost 115,000 employees around the world, 21 countries. So we are a big group. And this group has like almost in the 2024, 31 billion euros of business volume, and it's still growing. And almost 10% what we do in this number comes from online, directly online. So we sell a lot of products, a wide range of products, to help customers to renovate their homes. We have a motto, we make a home positive place to live. So it's the name, the motto we have at Adeo. And
yes, let me talk about what we are doing with the search. In Adeo services, we build our own software when it is important for us. And for the search engine, we build everything with Elasticsearch. Elasticsearch is running on Elastic Cloud, and Elastic Cloud is hosted with GCP. And for all the AI stuff we will talk in this presentation, we are using models from Vertex AI and Gemini for the LLM parts.
Yeah, and to start this presentation, we have a question that you might ask is, why do our customers need image search? It's a fair question, even more this morning, okay? So to get started, I'd like that you raise your hand if you know the name of this product. Who knows? Okay, great.
Yes.
Yeah. And I have a second one. And this one. This is a good question, you know? So this is the problem that all customers faced. They don't know how to name those products, so they don't know how to search them in the website. So the image search is a way to help them to figure out which kind of product this is and try to find a website, okay? Of course, for those who doesn't know, we are going to show during the demo and the presentation the name of the product. Stay stunned, okay?
So with image search, the first idea to build an image search engine is to use dense embeddings. The images are pretty unstructured data, but there is a lot of meaning within it, and embedding models can capture this meaning. So just a few words about what is an embedding model. You have in input different kind of objects. It can be text, it can be pictures, it can be videos, audios, and other things. You put it in your model. It can be a neural network or other kind of models, whatever. And in output, you get a dense vector representation, so in which every number, floating point model, will encode some information that describes the objects. Here we are making image search, and one common model to train is to use clip models. So what is clip models? You have pictures and captions, a lot of them, and you have two encoders, one for the text and one for the images. And if you train both models together to align the depth representations between the text and the image, from the image encoder, decoder, and encoder perspective, the output will encode features, text features that describes what is inside the picture. So it is very useful because we can use this representation in our work. For this work, as I said, we are heavy users of GCP and Vertex AI, so we go with multimodal embeddings from Vertex AI. It can take in input images, text, videos. We don't use it yet. And in output, we have multiple dimensions that can be used. For this presentation, this work, to have the highest numbers, we take the 1,408 dimensions, but lowest dimension can be used as well.
So how to work generally the architecture in the naive image? So we have the index part, I would say. First of all, we select, we get our product catalog. For this project, we selected the first photo for each product in our catalog. Then we generate an embedding for this photo, okay? And we ingest this in a specific index on Elasticsearch, and it's available for us. So currently, just using the embedding on this case, okay? And now we have the search part, where the customer have the UI. You send us a photo. And from this photo, we are generating on runtime an embedding and doing a KNN on this search, this index. So how it's this query globally? It's a both query in Elasticsearch using KNN. So we pass the query vector in the specific field we used. And then in the results, we are going to see the products that sort for Elasticsearch. And here is the visually what it's about. So it's you put in an image, then you have the results. In green seems there are good products in the results. And that's it. So thank you very much. I'm just kidding. Of course, I'm not finished the talk. It's just a joke. Because of course, during this project, we faced different problems. For example, dealing with embeddings, how to manage the memory size, the disk size, something that was new for the team. And also something that we are going to discuss during the presentation, how we balance the speed, search speed with the relevancy point, because we can be fast, but if you're saying wrong things, it's not a good deal for us.
Well, take a look at about the similarity here. You have in input this real-world picture. And the first result is quite okay. It is the same product. It is a hose connector. And you're right. And the same shape, the same materials, the same color. I think is okay. If you take a look at this one, okay, it is almost the same, but it is not a double-ended connector. So this one looks like the intended picture, but it is not the relevant product type. And when we show that to our merchandiser, they say, okay, people are looking to double-ended hose connectors and not this one. So we need to find all the double-ended hose connector. So here is the reason why just top K, not the product, which is great, but top K, KNN here is not enough because our merchandiser in an e-commerce perspective wants to show all the relevant products that match the product type. And they want to balance between the image similarity, okay, but also with the product attractiveness. By attractiveness, behind it is all the different business goals we have, show the products which have the best CTR, add to cart, sales, whatever. Here, LLM comes at rescue for us because with search engines building, it has always been a feature extraction problem. So here, LLM can be really, really good at extracting features from images, finding products within it, and generate caption over it. We don't show the prompt, but it is really, really easy to write a relevant prompt in order to get in output what are the relevant products within this image. Here in the middle, it's obvious it is a jigsaw that we are looking for, but there is also different kind of products within. There is a workbench on the bottom. There is safety glasses, safety gloves as well. So okay, we can use the LLM in order to extract what are the picture within, what are the products within the image. So with that, we can take the both of the best world, use the text extracted from the LLM to use our lexical search. We have text search for years, so okay, you have really well-crafted recipes over it. And we can use it alongside vector search.
So if we see the architecture for the hybrid search, on this part generally doesn't change from the first part that I explained earlier. We continue to generate the embedding for the first photo and store this in an Elasticsearch index. But with the hybrid, we also have the lexical part that is inside the same index. Okay, so it's just a little bit different in this case. And here is where the things get interesting. So when customers are sending an image through the UI, we are going to do two things in parallel. The first one, generate the embedding. So this remains the same. But at the same time, we are asking the LLM to describe, as François said earlier, what are the objects inside this photo. We extract these keywords, and we do a lexical and semantic search in the Elasticsearch. Okay. Generally, how it look like. So we just add a new calls with a match query. In this case, from what the LLM said to us, it is the main object of this photo. So in this case, it's a jigsaw bush. And we do, at the same time, a KNN. Okay, so we are looking for documents that match lexically and based on the visual similarity on the embedding. And then, thanks for the lexical approach, we can identify and do entity matching. For example, we saw that based on the query, we have a jigsaw, so we can boost this kind of product. Then for the same for the brand, like Bosch, we can boost. And then for the KNN, okay? So it's a way also to apply the merchandising rules. There's something that already exists previously and try to improve the query. So here is a demo. Let's see how it's going to work. Let's hope, yeah. Great, so we select a photo that you saw previously. Then, in the left side, you are going to see the KNN only results. And in the right side, you are going to see the semantic and lexical approach together, okay? The results are a little bit better because it's more close what we are looking as a product, but it's not even yet the good results we are looking for, okay? And François will explain later why this is happening. So let's up. And of course, comparing the naive with the hybrid approach, speed comes as a cost. So it would depend really the fast that you can do the inference to generate embedding. So in our case, sometimes the LLM, the embedding model goes very fast and others no. So in general, we can take like 3 seconds to do this, generate the embedding and do then the search. In the hybrid, since we are doing parallel, but we have the LLM call that takes more time in general. So what we can see that independently in this case, we are increasing the response time. We need to balance this in some way.
So what is important here is that with the LLM, we can give control about what is the feature extraction on the images, and we can generate caption, maybe start entity recognition as well. It is quite useful, but it is slow. So okay. The second point is that with the LLMs, we can run both lexical and semantic search alongside and have a good control of what the image organizer needs in the ranking stuff. So we have said that it works sometimes, it works not perfectly somehow also. So let's measure the relevance. And to be fast, we will do it with LLMs as a judge. Here we are not intending to give the best golden standard for building LLM as a judge, just to have clues about what happens in our engine, and it works pretty well. So in order to have an LLM as a judge, you need to build a golden data set. So here we'll collect many product indicators that we know that it will be hard to find with image search. So for example, here a garden host connector. Okay, you need the picture, but you need also to register different user intent, because it will be useful for the LLM to grade what the relevancy of the results, and it depends on the user intent. Okay, you have a lot of images. You can run the search, get results, so the pictures and every text that is shown displayed to the users, and run the LLM to grade the results. And here, what is important is to put the user intent with the picture, and also the merchandiser needs in order to have quite a good grade. And okay, you get grades for each product. And to make it simple here, you just made an average of the grades, but you can use all your favorites ranking metrics as well. It works. So what is happening? The naive search relevancy is around 65%. Right? Okay, the hybrid is 63, almost the same, a little bit lower, but it's not the problem. And if you take a look on the histogram behind it, there is a lot of queries where the search is really, really improved. And in other cases, the naive works better than the hybrid one. What is happening? If you just run the LLM, just take the LLM output, no the image similarity at all, the relevancy is only 46%. Okay, and what is happening? It is interesting is that we all know that if we merge bad results with good results, we only get bad results. And here it's not exactly the same. But in fact, when the two lexical search works well, the whole really works very, very well. I will show two use cases where it fails. The first one is, in fact, a textual problem. On the left, you have the KNN results. And on this result, you can see, OK, it works very well. We find double-ended host connectors, sorry. But for this kind of products, we have not set correctly the entities matching on it. It is not in our knowledge graph, host connectors, in fact. So if you are looking for, by text, host connector on the right, these products will not appear. So it's a textual problem, in fact, in the text search. It doesn't work also. That's the first problem. The second problem here, it is more grade related. In fact, the product here is also a host connector. And in fact, it is a very good host connector because it is a host connector that can prevent water leakage. And here there is the core problem here. With image search, what do we want as a merchandiser? Do we want to find exactly the same product visually, or do we want to provide advices to our user and provide him the best product for him? And this one is better for him. But if you do so, the LLM will judge that this result is not relevant. So it is not easy to write, in fact, LLM as a judge here, because this result is in fact good. The second problem is that the LLM may go wrong, in fact, at describing the products. In this example, sometimes it is otherwise, it depends how you set your API call. But okay, LLM sometimes says it is a wooden desktop. Okay, it is not true, but it's true. But In our business, Windows Desktop almost refers to Windows Desktop for kitchens and tables, not for workbench, like here. So, okay, here the relevancy is just bad because we don't provide a good product nature, in fact. When does it match? When does it match very well? For this example, the product in the middle is a brass fitting. I did not check. Not evident. An elbow one, to be exact. Why the K9 fails here? It's because the image is cluttered with many, many products, and it is not easy to identify what is the main product, even in the dense vector. So, on the left, in fact, the similarity is okay, but it is not focusing on the good products. By using the LLM, you can identify it is the brass fitting, and by doing so, we can get really relevant products. And in fact, in this case, visual similarity is not useful, to be totally honest. Mm-hmm. Another case where the hybrid search works very well. Here you have a dog-shaped lamp.
We saw this.
Yeah. Yes. The first result on the both sides is pretty relevant, no problem. But if you go deeper in the results, the next result on the K9 will be dog-shaped statues. And it is not what you want to sell to the user, the customer. The customer is looking for a lamp. So, okay, on the right, you have dog-shaped lamp. And if you go deeper, okay, you have not so many dog lamps, but you have animal-shaped lamps. So, okay, this result will be better for the user. So what is important here to mind is that when you do hybrid image search, first, you have a lot of work to do with the text search.
So the next part of the presentation, we will focus on the scaling part. We have a catalog with marketplace products and specific products for Leroy Merlin that take up to 10 million references. Okay, so this is something that you have to do in your catalog. So the first challenge with embeddings when someone started to use them is that, of course, they take more space than keyword index in general. So on the beginning of this project, we decided to do estimation and see, okay, probably how much memory and disk how we will need on this feature. So we have, for the memory part, globally we will need 54 gigabytes of memory distributed across all shards to put all embeddings in this case. The second challenge, also in some way, we have another index to manage, the vector index 2, that takes some significant storage. Doing the math, we have like, okay, it will be like 3 gigabytes of memory that we need to have for this part. That in the end, we thought that we need almost 60 gigabytes of space and memory to deal with these vectors. If you take in consideration with the hybrid part, adding the currently keyword index, we will have almost 100 gigabytes of memory for the disk. 100 gigabytes for the disk and 8 gigabytes for the memory, if you take in consideration the vector and the keyword index. Okay, so it's much more that we expected in the beginning, but the reality
is a little bit different.
Yep.
If we take a look at what happened in Elasticsearch, we are expecting 97 gigabytes of data, and we go in reality to 207 gigabytes. What happens in Elasticsearch? By default, all the vectors are stored in the sources. It is pretty logic. But there is also copies of the vectors for the indexing process. If you need to reindex your data, okay, you need the original vector. And you need a copy of the vector for the search phase. So, in fact, you have 3 times the same data. So one obvious question for us was to use quantization and to reduce the memory size and storage size. This picture is coming from Elasticsearch. Some people know it. well, if you reduce the encoding of the numbers in the vector, you're just removing information from the original image somehow. And if you go further and you go to bit quantization, okay, bit quantization is just keeping the positive features and put it to 1 and the 0 to the others. Okay, you can still guess what it is or a bit, but it is only the remaining information you have. So you can imagine that we will lose a lot of relevancy by doing so. But if you just focus on storage size, okay, on memory, if you go to int8 quantization, you just divide the numbers by 4, okay, on the memory size, it is pretty good. On the disk size, what happened is that you have even more data. Why? Because you have a copy of the int8 vectors for the HNS index, in fact. We are, it's an advertising moment. We are gardening specialists, so we are producing our own barbecues, and when Elasticsearch come out with a BBQ, you can think it is a good config for us. So what is BBQ? There is engineers from Elasticsearch here, so I will not go deeper in the explanation. Just if you compare to bit quantization, the better bit BBQ will use some centroids of vectors that are very similar. Just do the bit quantization around the centroid, so you keep a lot of information which is relevant to describe the products and in the image here. So, well, it works very well, and we show that. Here, if you take a look at the memory, basically you divide everything, your memory footprint by 32, so it is pretty efficient. And for the disk size, as you can see, you have still one more copy of the vectors that are binarized, but well, it doesn't take so much memory, so much storage here. And let's go to the numbers. It's me? Okay. Here, it is very, very efficient at search phase. In fact, in the latency is quite lower with BBQ than with the float number. So, okay, it's good for the performance. And for the relevancy, there is almost no difference. So our lesson here for image search is that BBQ is pretty efficient. And it is became relevancy, as we do with the LLM as a judge. So, okay, we can think it is quite good for us to go with the BBQ. It becomes the default in the last version of Elasticsearch.
Yeah, and in this part also some other ideas that you can try to do to improve the disk part. So, of course, you can exclude vectors from source, something that you can remove if you would like. We did an experiment with different vector dimensions to see if it's improved or not. Of course, we improve in the terms of disk space in consumption, but we don't try out to see if the relevance change doing this. That's something that you can take a look. And also for the LLM inference, you can try to fine-tune a SLM or have a dedicated hosting to try to decrease the time of response on the hybrid part.
Well, we are coming to the end of this presentation. So what is important to retain is that LLMs are very, very good at extracting features from the pictures. And it works well, but in fact, with the art pictures, people will come with new vocabulary that we are not dealing necessarily well in our knowledge graph, in the way we do search. So if you want to do a good text search, if you want to do good image search with hybrid architecture, we need to improve also the text part. But it works well when everything is aligned, and we are pretty happy with that. And also using the lexical search allows us to align the business needs from the merchandiser. It is very important for us. The second point is that in order to make it fast, low footprint, and so on, BBQ appears to be, in our case, a good option to run everything. So it's a good lesson for us. let's have some few words about the UX here, because we are just creating a ranking system in the back. We are also building user interface in order to look for. And if you, yes, you can start.
Okay, great.
Here it is what you are building for the application. Mobile app? No, I cannot. But here, to build the user interface, in fact, you can use LLM as well. It is interesting for the user to know how we understand the image and to show them that we find this product with this name into the user interface. I think it is like what we said yesterday about autocomplete and search as a type. We need to give feedback to our user about how we understand his intent and the image. And here in the example, okay, you just do feature extraction, but maybe we can also ask to the user, what do you want to do with that? You can add text input also alongside with the image. We can do many things, in fact, because what is important is to guess and understand what is the user intent, and not just understanding just the image. As I said at the beginning of the presentation, there is many things to do. One thing that is obvious for us, if you have a caption from the LLM, we can use it in the multimodal model to do a dual search. One with the image vector, okay, and another one with the text vector that is derived from the LLM and the caption. As Guitte has said before, we have many pictures for each product. And in fact, maybe each picture can be vectorized as well, but okay, we will have a big index in order to do that. So there is an interesting point here is that it exists some interleaved embedding models. I think that I only one Voyage produce one that works pretty well in the benchmarks. And in fact, you can put everything in the model, the text, description of the product, the different images, and produce just one vector that encodes every feature of the product, and not just running many vectors in parallel. Sparse embeddings seems to be interesting as well because LLMs are pretty good to produce sparse features, but you need to control the feature naming. But I have not seen yet a sparse clip model, so I suppose there is some room of improvement here. And the last point is that, in fact, there is many ways to re-rank stuff. Input, we have used LLMs in order to extract feature. Maybe in output, we need to judge what is the best way to rank, what is the best results to show to the user. Maybe just judge if it is more clever to show only the KNN or just to show the hybrid. And maybe in input, the LLM can help us decide what is the good recipe to play, and not just put everything in just one recipe. This is my final word.
And I'd like to, we are going to conclude this talk. First, I'd like to do a special thanks for our contributors, like you said, that is here in the audience too. Something for your work during this project. Of course, we are hiring other contributors. Feel free to reach us. And thank you very much for your attention.
Thank you very much. There's one urgent question.
Merci per la présentation. I wouldn't continue in French, that's fine. I know some of you Portuguese. Sorry. Very interesting, and I was doing a lot of, that's why the urgency, very similar type of projects in the DIY space, connectors and parts maybe and whatnot. The problem that we faced very often, and I don't know if you faced them, when you have these, let's say, plumbing connectors, etc., they all have different dimensions. They need to fit. It doesn't about only just a match. They need to have like a, and parts talking, of course, tires could be different size, small, nuts, and etc., etc. So I'm just curious, do you have any problems like this? Do you Do you try anything to solve this type of problem?
Yes. What we are doing, I think the point is very important for Leroy Merlin that we try to show products that are met together, mostly. What are helping us currently that we're trying is to use LM to generate rules that we can infer compatibility features between products. Okay, it's helping us to get these features and have I would say a graph where we can see which are the compatibility products. This is something that we are using, but it's still something new for us, and we are trying to see the different results we get. Of course, it's something that sometimes it works well, and other times you see the specific points we cannot just capture with the description and the image. It's something more. That is why the LLMs is something interesting, but because you have that knowledge that's sometimes can hallucinate, but sometimes it's bigger that we have in the product.
I think this is a good question because it is where we see that search engines and recommendations engines is somehow the same problem. In this case, maybe you can use promises from recommendation engine first and not just thinking in the search way.
Thank you. I want to take a question from the online audience. So the first one is, how do you select a single image from the product item? As I assume there are multiple images in the product data. You mentioned first image. How do you get the first? How do you order the images?
In the prompt, in fact, you're asking the LLM to measure the importance. We let the LLM judge it. It is, I'm going back on it here. You have asked the LLM to give an importance of the objects. Okay, it is just for the purpose of the demonstration because we want to find the first product. But I think that what is important is to provide a good UX to answer that question and let the user find and click on the relevant product by itself. Because, okay, you can give an interpretation of what you are seeing in the image, but if you can display all the different options, the user can express himself by a click and go further.
And for the embedding part, the selection, we do use as an intuition the first image represents a good way the product, so we select the first one for the part.
Okay, so you basically take what you have in the data and use the first one. Okay. Another one from online. Are you generating embeddings on the fly, or do you do this cyclically with batches?
For the indexing part, it is batches and cache because the images pictures doesn't change every day, in fact. And for the online part, okay, here it's just a prototype, in fact, and we don't put any cache layer. And I don't think it is really relevant, in fact. Just so okay, we generate the embedding on the flight.
For the query, don't have a choice.
Okay. I've seen more hands.
First main question.
That's good.
Yes, thank you. This question: how did you prepare the golden data set, and what is the volume of this data set?
It is something unwritten, to be totally honest. I have used the help of an LLM in order to select relevant product natures that are be useful to find with the image picture regarding our catalog. And for the user intent, generated by myself, I know pretty much the business. Okay, it's easy to write down some relevant intent and just use the LLM in order to create the intent regarding the product nature. For the pictures, I am used to say that with the LLMs, it's quite easy to generate synthetic data. But for the images, it is not easy, in fact, because what we want here is to have real-world pictures, badly taken with your cell phone and with bad contrast, bad colors, and bad angles. So, well, real world. So what I've done, yes. So what I have did is just going on image search on Google and find out relevant pictures that can be made by our users.
Thank you.
Yes, Thank you for the presentation. It was a great keynote. I had a question on the user experience, but you kind of started to answer it in the end. So it's great that you took that into consideration. Also, the question was so obviously you already did thought about presenting the results in a different manner than just products and that you can click on. So like presenting maybe a text with questions or maybe a technical documentation that also tells that, okay, this product maybe is discontinued and you should replace it with that and that, or you shouldn't pay attention to the compatibility with other products. So yeah, how do you handle that? What's next for you in this area? And the second question is like technical around Elasticsearch. So are you using all this with Elastic Cloud, like machine learning nodes and all that, or you're doing all the embeddings and all that outside Elasticsearch and then send the vectors to Elasticsearch?
For the first question, currently we think that with the business feedbacks we will get, we can choose what are the relevant ways to answer to the user. And I think maybe that the next step will be use the LLM in order to route the query to the good recipes, in fact. I think there is a lot of interesting patterns with agents architectures, and we can use the classification, the routing way to do that efficiently. And maybe if we guess that the problem is a recommendation problem, okay, go to the recommendation engine and not to the search engine. Not know yet. We will do that, but this is what we are thinking currently. Yeah. And for the second point, in fact, we are doing the both depending on the project. On this project, everything was made outside, but recently Elasticsearch has introduced endpoints to query Vertex AI. So I think we can use ML nodes, not directly hosting the model, but as a proxy to our models on Vertex AI.
Thank you. Did I see further hands over there?
Just on the point of embeddings, so are you embedding only the images? Do you embed images and descriptions? And which models do you use specifically? Because I would imagine, like if you take the jigsaw like picture from Bosch, telling it like jigsaw the picture and like jigsaw or something would embed to something like more specific, and then again it has to match like the user intent and whatnot.
Yes, in fact, there is an interesting paper that is, I can't remember the name exactly, but which is saying that almost every feature encoded into the text vector from an image is text description. So, well, for this prototype, we just focus on image vector, but in fact, we can do the both, as I said before, and make a dual run. So multimodal embeddings from Vertex AI support really well both text and images. But to be honest, I'm waiting for multimodal Gemini embeddings because it will be more useful for us to put every information from the product, the tags, the different attributes, and so on, and also the different pictures. And there is a lot of pictures. Some pictures are not useful for us. You have a picture of the product in the inner angle, in the other angle, and so on. Okay, we don't get so much information. But there is a lot of pictures that are showing the product in usage, and this one are useful for us and can give us new features, in fact. And I think that you must encode everything in just one vector.
Okay, thank you. A final question from the online audience. Which models are you actually using for images and text? So what models are you using finally?
Sorry, I didn't
Which models are you finally using for the embeddings?
Multimodal embeddings from Vertex AI.
Is this one.
And this one.
Oh, you said it. Okay, yeah.
No problem.
Answered. Okay. All right, so let's thank our speakers again and then take the next talk.
you.